Hello guys, today we'll be doing trigonometry as I promised you. So um firstly I'll divide it into small sections to make it easier for you to understand, guys. And then I'm not sure if we'll cover all the sessions today because I don't want to chow your data. So without wasting any more time, guys, we'll jump right into my screen and then we'll take it from there, and then we'll see how far we can push. So without wasting any time, guys. Okay, awesome. So as I said, we'll be doing trigonometry, and then firstly we will start with, oh Jesus, sorry about that. We will start with doing squares and triangles, because trigonometry it's mainly on triangles. It's mainly on triangles. So it's mainly triangles, but before that, I'd like to do squares as well. You'll see why, and surely you'll understand. So guys, without wasting any time, let me explain. So this simplification, the definition I got here for you guys for a triangle, it goes as follows. It says a triangle is a geometric shape with three sides and three angles that you already know. Some of the different types of triangles are described in this unit. So what I did here, guys, was to create some form of document to make it easier for you to understand. So what I'll do after these sections, I'll send you question papers, or rather questions, based on what we would have covered today, and then you'll tell me whether you understand or not, because based on those exercises, I'll then be able to tell whether you did understand me or not. And then remember that, guys, the good thing about these videos is that you can repeat them as many times as you want to until you understand. And if there's something that's not clear, you can ask me, guys, obviously after repeating the videos. So we just got a definition of a triangle. A definition of a square is that it's a four-sided geometric shape with four sides that are equal and four angles that are the same size. So those angles that are the same size would be 90 degrees each. But for the triangle, remember, they don't have to be 90, they don't have to be equal, but the sum has to be 180. So when we add all the three angles of a triangle, we must get 180 degrees. And then when we add all the four angles of a square, we must get 360. That's not just only for square. In any quadrilateral, you should get 360 when you add the angles. But today we are not doing the quadrilaterals. But I hope you know what the quadrilateral is. Any object that has four sides. So guys, without wasting time, let's go to the different types of triangles. We have four different types of triangles, but trigonometry mainly focuses on one. Yeah? So we have an isosceles triangle, which is a triangle that has two equal sides and two equal angles that are at the base. Yeah? So this is pretty simple, guys. It's easy to understand. We have two equal sides. You can see our sides there. Then we have two equal angles. Easy. So when they ask you in an exam for properties of an isosceles triangle, this is what you give them. Two equal sides, two equal angles. But for the angles, you have to be specific. Two equal angles that are at the base. Are we clear? Hope we are clear, guys. That's very easy to understand. And then that was triangle number one. So we are done with that one. Then triangle number two, it's the equilateral. Don't confuse that with the quadrilateral I just told you. It's equilateral. Equilateral triangle, equal, from this word here, equal. Think of equal, guys. So equal triangles, equal angles. So it has equal angles. And remember, we said that the sum has to be 100 sorry about that. The sum has to be 180. So for the sum to be 180, for it to be 180 degrees, each angle has to be 60. So 60 multiplied by 3 will give us 180 degrees. I hope it's clear, guys. So far we have our 3 triangles. Triangle number 1 being our isosceles, triangle number 2 being our equilateral triangle, and triangle number 3 being our scaling triangle. This triangle, the properties for it is that it doesn't have any side that is equal to each. No sides are equal, no angles are equal. We don't use this triangle most of the time, but you have to know how to identify these triangles. But so far, what I told you is that we have 4 different types of triangles, but here I've only mentioned 3. And then you might be asking yourself, what is the 4th triangle? The 4th triangle is quite simple, guys. It's what is it will be our main focus when it comes to trigonometry. So you can't claim that you know trigonometry unless you know this triangle. So it's what we call a right-angled triangle. Right-angled triangle. It's pretty easy to understand, guys. Right-angled triangle, and it's self-explanatory. Right angle, what do you know from right angle? We know that it's 90 degrees, as we can see here. We can see here this angle. We know every time we see that angle that it represents 90 degrees. So a right angle triangle is a triangle that has 90 degrees as one of its angles. Are we clear, guys? Awesome. So trigonometry will apply it on this triangle here. I didn't name it here because I'll put much focus on it later on. So without wasting any time, guys, let's carry on. Let's carry on, guys. So this is pretty easy. So by now you understand the 3 types of triangles. And then for the square, we'll do much of this when you're doing measurements for squares. So the reason why I wanted to, you might be asking yourself, why am I including these squares on trigonometry? Remember that a square, we just said all the angles are equal. All the angles are equal. And then we said all the angles are equal, each being 90 degrees. So you'll have your 90 there, you'll have your 90 there, you have your 90. All of them, remember, they must give us 360, which is obvious, guys. So if we were to divide this to draw a diagonal line here, we would have triangle number 1 and triangle number 2. So this is what they will do in your exam, guys, to trick you sometimes. They would give you, if this is 4 centimeters, obviously this is also 4, this is also 4, this is also 4. Because in the properties of a square, we just said all the sides are equal. I hope you understand, guys. So if this is 4 here, and this is also 4, and then you have your 90 there, how do we know we have a 90? Because it's a square. Even if they didn't give you that 90, you would put that 90 because you know that it's a square. You know the properties of a square. Easy, guys. I hope you're following. Then from there, we would be required to calculate either the length of this diagonal or the angle there or this angle here. So that's very easy, guys. It's either we calculate the size of this diagonal line, we calculate this angle here, or that angle there. That is all about trigonometry at your level, guys. There's more. Yes, there's more. We'll do that later. But once you master what I just told you, because sometimes they can give you that angle and require you to calculate a side. They can give you 2 angles and they ask you to find a side, or they give you two sides, you find another side and an angle. So we'll do those examples. It's easy to understand, guys. So all the reason, the number one reason why we were doing, why I introduced the square in this lesson is for you to understand that if they give you in this in your exam, don't be surprised, guys. Just draw a diagonal line. Just know that we have 90-degree angles all around. I hope we are clear, guys. So moving on, I will send you exercises, guys, because if we can try to do each of them here, we'll waste time. So here, what I put here, this section is just to check if you really understand what I just explained right now. So it's asking you to state whether the following triangles each is a scalene, isosceles triangle, or equilateral. So to revise, remember equilateral, I said the word equal, all the angles are equal and all the sides are equal. Isosceles, two sides are equal, two angles are equal. But for the two angles that are equal, you have to be specific that two angles at the base are equal. Then for scalene, the angles are not equal and none of the sides are also equal. So as from this one, we can see we have 6 centimeters, we have 6 centimeters there. And then, meaning this side is equal to that side. So which angles will be equal? It's this angle and that angle, not that one, guys, because that's not the base. So it's this angle. The easiest way to remember this is that the angle opposite those two equal sides. So the way I use to remember this, guys, is that this angle is opposite that one, and this angle is opposite that one. So these two angles, we expect them to be the same, not that one because it's opposed by 4, and 4 is not equal to 6. I hope you understand, guys. This is pretty easy. And this obviously here, this will be your scalene because we have 6, 7, and 8. Those sides are not equal. And if the sides are not equal, none of the angles are not equal. And then what you'll see in your exam most of the time, they normally use these lines. You see curved lines like this, curved lines like that. So those lines they use, guys, is just to represent that the angles are not equal. So we have 1, we have 2 lines, we have 3 lines. For this one, to indicate that the angles are equal, you put 1 line each, or 2 lines, and then 1 line each. Then you can put your 2 lines there to show that it's 1, 1, meaning they are equal. So this one is 1, 2, 3. They are not equal. Are we clear, guys? Then for your equilateral triangle, this would be the case. This would be the case because remember, all the sides are equal. All the sides are equal. So if all the sides are equal, guys, meaning that side is equal to that side is equal to that side. Sometimes they also use these lines. So for this one, this side here is not equal to that side. So they can represent that side by 2 lines. They can represent that side by 3 lines. Maximum is 3 because, I mean, a triangle has 3 sides. Then for this one, they can put 1 there. Then they can put 2. They can put 2 again. Why 2, 2? Because these sides are equal, guys. Then for this one, it's 1, 1, 1. Why 1, 1, 1? Because all those sides are equal. Then for using, if they decide to use curved lines as they can use, they can use 1 here, 1 there, and the last one there. So the last one there, which would also be 1. So it's 1, 1, 1. Just showing you that all the angles are equal. I hope that makes sense, guys. So without wasting time, let's carry on. So you'll do all of this. You'll carry on with all of that. It's everything that is there. It's everything that we did. And then here they're asking you, when a square is cut in half diagonally, 2 triangles are obtained, as I explained. Are these triangles scalene, isosceles, or equilateral? Okay, guys, this is pretty simple. Pretty simple. as I explained, we divide this into two, we get two triangles. We have 90 degrees there, we have our 90 there, we have 90 here, we have 90 there. Easy, easy, easy. And then one other thing you have to know about a square is that if they draw a diagonal line, the diagonal line divides the two angles equally. It divides these two angles equally. So what does that mean? What is the equal of, what is 90 divided by 2? So we would have 45 degrees there. We would have 45 degrees there. 45 degrees, then we would also have 45 degrees there. 45 degrees there. Easy to understand, guys. 45, 45, forgive me for that handwriting. So we'd have 45, 45, 45 plus 45 will give us the total of 90. So when they are asking you if this is an isosceles triangle or not, how then do we come about to answer that question whether it's an isosceles triangle or not? It's very, very, very easy, guys. Very, very easy. So remember we said all the sides of the square are equal. Then if you take this triangle here, if you take this triangle here, let me draw it, guys. If you take that triangle, I'll draw it here. Take one triangle, it will be something like that, with this being our diagonal line. Yeah? Okay, let me use a yellow color. Let me use a yellow color here to make it easy for you to visualize what I'm saying. Awesome. So this is that triangle there. But remember, we have our 90 here. We have our 90 there. This is your diagonal line. Then these sides are equal. What did we say about sides that are equal? What did we say about sides that are equal? That they will have two angles at the base. Two angles at the base that will be equal. So this angle here and that angle there would be equal. How do we know it's these angles? Remember the trick I just told you to use, that this angle is opposite that one and this one is opposite that side. So expect these two angles to be the same size. So this would be 45, 45 plus 90. That will give you 180 degrees. Are we clear? This is very, very simple, guys. How did I know that it would be 45 and 45? Because we know that the sum of the sum of triangles should be 180. It should be 180. So 180 minus 90 already, because I already have that 90 there. It's 180 minus 90. 180 minus 90 is 90, guys. So I'm left with 90, and I'm left with how many angles? 2. So I will divide that 90 by 2. Divide 90 by 2. What do you get? You get 45. So it's 45 each. Sometimes they will give you this scenario in an exam. So when they give you this scenario in an exam, what do? You represent these angles here with x. So it will be x, x. Why x and x? Because it's the same. So it will be 2x plus 90. I hope you're visualizing what I'm saying, guys. It will be 2x plus 90. It's equal to, or before we get to 2x plus 90, you obviously start by saying x plus 90. X plus x plus 90. 90 plus x plus x. It should give you 180. And remember that when it comes to such, you should always give your reason. Why are you saying that it should be 90? Your reason will be sum of interior angles of a triangle. Sum of interior angles of a triangle. And then from there, you'd say x plus x is 2x, guys. X plus x is 2x. Then you take your 90, you transpose it. So you'll have something like 180 minus 90. Then from there, you have your 2x being equal to 180 minus 90, that's 90. Then from there, you divide by 2 on both sides. You have your x being 45 degrees, which is the 45 degrees I just told you about. So this is pretty simple. Then you finish all of this here, guys. We finish, find the areas of the squares with the sides. Okay, for the areas, we want, I'll just give you the formulas for now. Ne? So what I want you to do for me, guys, I want you to check your textbook if it includes these areas and everything that I'm doing under trigonometry, or it just talks about the triangles. Are we clear, guys? But if it's telling you, or it's including this, these squares, the area for square, it's equal to L multiplied by L. L multiplied by L, or we can say L squared. What is L? L is length. Ne? L is length. L represents your length. And then you can also see W, which represents your width, which is also represented. They can either use B or W. B is breadth. So W and B is the same thing, guys. It's the same thing. I hope you understand. So the area for square is L multiplied by N, which is L squared. So if they say find the area of a square with the side length of 2, we just say you must always write the formula first. So it will be A is equals to L multiplied by N. So you substitute that with 2. So it's 2 multiplied by 2, which is 4. And then for your area, always guys, include your units. But for your area, always the unit is squared. So it will be 2 multiplied by 2, it will be 4 meters squared. I hope you understand. And for this 100 multiplied by 100, that would be 1, 2, 3, 4. That would be 10,000 meters squared. Then you do the same with this one. It would be the answer you get centimeter squared. The answer you get centimeter squared. And then, guys, if I give you this, then you don't understand any of the things I'm saying here, just let me know. Just let me know. So let's continue, guys. Let's continue. We'll do all of those. So that was section 1. So going to section 2. Section 2 is Pythagoras Theorem. So Pythagoras Theorem is mainly on the right angled triangle. It's mainly on the right angled triangle. It's just this triangle, nothing else, guys. It's just that triangle, nothing else. Hope you understand, guys. It's very clear. Right angle triangle. Meaning all of the other triangles, you can't apply the Pythagoras theorem except only on the right angle triangle. So let me explain something to you very quick, guys, to make it easy for you to understand. I hope you're with me so far. So far, I hope we are together. So let's suppose you have your triangle there. Sorry, guys, there's something wrong with my, I don't know. 90 degrees. Ne? So when you have your 90 degrees there, you have your 90 degrees there, guys. You have 3 sides, obviously, because it's a triangle. And then side, all of these sides. The side opposite, always the side opposite the 90 degrees. Which side is opposite 90? This. It's front opposite. So it's this side. So this side. So the side opposite 90 degrees, we call that side what? Your hypotenuse. Hypotenuse side. Easy. Side opposite 90 degrees, we call it hypotenuse side. So in this case, our hypotenuse would be A. Are we clear? Awesome. And then another side, this side, if you're facing the triangle as you are right now looking at your phone, and in the looking at your phone, this side here, this side, we call it your altitude. We call it your altitude, but we'll use different terms, guys. But to make it simple for you to understand for now, this side, the straight one, the height, it's either called the altitude or the height. But you know, we like being fancy, so it's altitude. We clear. And then this one here, this side here, the last one, the one here, we call it the base. The base. So the one opposite the 90 degrees is hypotenuse. The one that is straight going upwards is your altitude or height. Then the other one that is going horizontal is your base. But the base is also called the adjacent. Adjacent. So it's either called the base or adjacent side. This one, we will call it the opposite side. So we will use these terms. We won't use the altitude and everything. We won't use the altitude. We will use opposite, adjacent, hypotenuse. So know those ones. But if your textbook is saying something like altitude and base, don't be surprised. But for me, stick to opposite and adjacent. I'll show you one, because I'll give you a simple way to remember everything that I'm going to teach you. But you only if you are using opposite, adjacent, and hypotenuse. Are we clear? Awesome. And then, what is the Pythagoras Theorem saying? It says that if we square the hypotenuse side, if we square this, the sum of it, or the answer that we get, will be equal to this squared plus this squared. So what Pythagoras was saying basically was a squared or hypotenuse squared is equal to the altitude or opposite. But since I said we'll be using opposite, let's stick to opposite. So the hypotenuse squared is equal to the opposite squared plus the adjacent squared. I think we are clear on that one, guys. So we have an example here. On how to calculate. And then the only thing here to be careful of is, you know, in your exams, when they give you the instructions, they always tell you to round off your final answer to 2 decimal places. They can sometimes say to 1, so don't grab. Ne? So it's important for you to round to whatever number of places they're asking you to do so. So this is an easy example. They are saying we've been given a triangle. We have 4 as our opposite side. We have 6 as our adjacent. We don't have a hypotenuse side. And then they're asking us to calculate our hypotenuse side. So the first thing to do here, guys, is to write the correct equation. So you write your equation, you get 1 mark. That's simple. Write your equation, get 1 mark. Then the second step is for you to substitute. You substitute, you get another mark. 3 marks, guys. Then after substituting 4 squared, I'd advise you to put this in brackets. 4 squared, for the 4 in brackets, the 6 in brackets. So 4 squared is 16, 6 squared is 36. You get another mark. Then you add those 2, it's 52. But since we want to remove this squared here of a, because we want a, we don't want a squared. So the only way to remove that squared is by introducing a square root. But remember what I told you, guys. I told you that always when you remove a square root, your answer will be plus minus. But in this case, there's no way on earth, guys, you will have a side that has a negative answer. You'll never get a side that is negative. They are always positive. So that's why they didn't even bother here to put a plus minus sign. So you'll also get a mark for understanding that you should square root then for the final answer. So that's about 5 marks, 3 marks, guys. just pressing your calculator. So that's easy, guys. That's easy. That's how you apply the theorem of Pythagoras. So they can trick you sometimes by putting other letters. It's the same thing. So here you have your hypotenuse, you have your adjacent. You are looking for your opposite. So what you do, the first thing you do, you write your formula, you substitute. But this case, in this case, we have the hypotenuse, we have the adjacent. We are looking for the opposite. So what you do from there, remember what I told you when we were solving for x. Remember what I told you the other day. If you don't know how to solve for x, you can't claim you know maths. You don't know maths, guys, because solving for x comes now and then, now and then. So here, what we are supposed to do is transpose, take that 9 to that side. And then you get the answer, you square, you're done. Easy to understand, guys, easy. They can ask you to calculate the opposite, they can ask you to calculate the adjacent, they can ask you to calculate the hypotenuse, but they will always give you the two other sides. So all you do is just rearrange the formula. But critical, very important, guys, always write the original formula first. A squared is equal to b squared plus c squared. You'll see other textbooks, most of the textbooks nowadays, they don't use a squared, b squared, and c squared. So our hypotenuse most of the time is labeled as r. Our adjacent most of the time is labeled as x. Why x? Because it's horizontal, it's on the x-axis. Do you get it? Then our opposite is y. So the new formula would be, not the new formula, but the formula you might see is r squared is equal to x squared plus y squared. It's the same thing, guys. It's this a squared and everything. And myself, I prefer this one because I always use that one. R squared is equal to x squared plus y squared. So if you see this in your textbook, don't be surprised. If you see this one here in your textbook, don't be surprised. It's the same thing. But my preferation is this one because we are going with the times, guys. And then I hope you understand so far. Hope you understand. If you're tired, you can pause the video and take a break, guys. Come back, I'll send the exercises. So you'll do all of those exercises. Do all of those. I'll send them, don't worry. You do all of those there. They are very, they'll check if you, okay. This is just, they can treat you with Pythagoras by combining more than, by having more than one triangle. But it's the same thing. If you don't understand, let me know. Let me know, because it's very easy to understand those things. If you don't understand, let me know. So you repeat the video as many times as you can. So, yeah, boo. Coming to the business of the day. The video is long already because it's about 39 minutes. Sorry. So we have trig ratios. Three trig ratios. We have three trig ratios. The first one being sine, the second one being cos, but full it's cosine. The third one being tangent. So most of the textbooks they use they cut these words. So sine, you see this is don't say it's sin, guys. No one committed sin. Sine. Cosine shorthand is cos. Tangent shorthand tan. Ne? So it's sine, cos, tan. Then most of the time they use theta. So you'll see theta, 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 sine theta, this symbol, this funky symbol here, 0 with something. We call that a theta. Here it is, guys. Here it is. There it is. Theta. So what's the meaning of theta? Theta simply means it represents any angle that you want. If you're thinking of 90, it represents 90. If you're thinking of anything, it represents that particular angle. Very easy to understand, guys. So as I said, we have sine, we have cos, we have tan. So I have a simple mnemonic for you to remember these things, because you must know this by all these formulas, all these three. You must know them. So the easiest way to remember this is this mnemonic I'll give you here. Oh hell, another hour of algebra. Oh hell, another hour of algebra. So you might be asking yourself, what is Taban teaching us right now? What is he saying? So for these two, for the first two, this oh hell is for sine. This another hour is for cos. Of algebra is for tan. So what am I saying? You take the first letter of each word. So you take that O, you take that O, you take that H, take that A, that H, that O, that A. The sentence is just for you to remember the sentences. So O hell for sine, it's opposite over hypotenuse. Another hour is adjacent over hypotenuse of algebra, that's tan, it's opposite over adjacent. You mess this up, guys, you are done. You won't get the answer correct and you'll be wrong. So that's the easiest way to master all of this. You don't have to cram, guys. You don't have to cram. Just know maths is fun. Maths is fun and it's easy. So don't make it difficult. Oh hell, another hour of algebra. So oh hell, another hour of algebra. Easy, very easy. And then sine theta will always have the same value for any particular angle, regardless of the size of the angle. The same is true. So this statement might be confusing for you guys. So we have five, sorry. We have 5 angles that are special. We have 0, 30, 45, 60, and 90. We call this, remember, since it's angles, you have to put degrees there. You have to put degrees. So it's 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. We call these special angles. I'll explain why they're special. Call these special angles because you can find their answers without using a calculator. Very easy. And they require you to do so because there'll be questions that will be like, solve this without using a calculator, solve this without using a calculator. But that will be easy for you guys since you're with me. For the triangle shown, state which sides are the hypotenuse. Which side is the hypotenuse? Remember, for the hypotenuse, you must first locate the 90 degrees. So the angle opposite that one will be the hypotenuse. Are we clear, guys? Easy, easy. So this will be our hypotenuse. This side, CP, will be our hypotenuse. Adjacent, oh, awesome. Awesome. I'm glad that I put this example here so that I can explain this. How do we then know? Because you can see that this angle, this triangle rather, is tilted. It's not like the other triangles I showed you. They were all straight like that. And then it was easy for you to locate that this side here is your altitude, that is your base. But in this case, In this case, there's no altitude and everything, it's tilted. So how do you then know which is which? So always the side that is opposite the angle you're given. I know that we are given 90 degrees. You don't include that 90. It's turn a blind eye to that 90. You don't use that 90. That 90 is just for reference as to which side is your hypotenuse. Then that's it. You don't use that 90. Are we clear? Then the other angle you are given besides that 90, that angle, the side that is opposite that angle will always be your opposite side. I repeat, the side that is always opposite to the angle that you're given besides 90 will always be your opposite side. So this would be our opposite. Are we clear? This would be our opposite, this side. Then the remaining side would be your adjacent. So for this one, opposite side is 8. Hypotenuse side is 10. The remaining is your adjacent. Are we clear? Awesome. Then you do all of those exercises there. It's very easy to understand. So guys, it's 46 minutes. I hope that's too much for you. You do that. And the answer you get when you're calculating for your angle, remember to always put degrees as they did. Degrees, guys. If you don't put degrees, that's not an angle. You don't know what it is, and then you get wrong. Do all of those, I'll send them. Do all of those, I'll send them. If you don't understand something, tell me. Okay, we'll do this in another session, guys. I feel like I've given you a lot already, and you have a lot to do. So once you are done with these exercises, let me know. I'm done, I understood. Give me exercises, and then once you're done with the exercises, I'll drop this section. I hope this will be our last section, because with the document I have, we have about, I created a document that has, as you can see there, about 43 pages, but I don't think we'll do all those 43. But the aim is not the 43, because I tried to create a document before so that it makes it easier for me to teach you. So guys, I don't end up teaching you things that you are not supposed to learn. I end up teaching you stuff of higher grades. See? So with that being said, guys, I really hope that you did understand what I just told you, and that it was easy for you and it was fun. So please, guys, be safe. You know, we are going through a lot right now as a country. So be safe, guys. Study and yeah, exercise. Keep your mind active, guys. And remember that I love you, but God loves you. Okay? And then continue to pray for our country, guys. So with that being said, guys, that will be it for me. And yeah, see you on another lesson.